Hi, welcome to our next level 1 tables, equations and graphs video. We're still talking linear functions and we're going to talk about rates of change. Now, rates of change is the correct term for a gradient. It's a way to compare two different variables, things like speed, which compares distance with time, or wages, which compares money versus time. Straight into example 1, we have a graph here. On the x-axis, we have time in hours, going up 1, 2, 3, 4, 5, 6 hours. And on the y-axis, we have distance in kilometers, going up in hundreds of kilometers. We're going to work out the gradient of this line, or the rate of change. So we're going to take the origin as our first point, and I found another point here. At 5 hours, we're up at 300 kilometers. So we can work out the gradient by working out the rate of change, we can work out the gradient by working out the rise over the run. To do that, we work out how much has risen. We're starting at the origin and we're rising up 300 squares. 300, I know it's 3 squares, but it represents 300. And we're running across 5 squares, which is 5 hours. So we're rising 300 and running 5. So 300 over 5. Now if I grab my calculator, 300 divided 5 gives me 60. So this has a gradient or a rate of change of 60. And because we're measuring distance versus time, we can say 60 kilometers per hour, which is a speed. So this car or vehicle is traveling at a rate of 60 kilometers per hour. Right, let's move on to example 2. Again, on the x-axis, we have time, and we're going up to 8 hours. And on the y-axis now, we have the income measured in New Zealand dollars. Well, again, we're going to work out the gradient or the rate of change, and we need 2 points. The first point's going to be our origin, and the second point, I found a point here at 4 hours. We look to be somewhere between exactly 80 and 90, which I think 80 to 100, sorry, which is going to be 90. So to work out the gradient or rate of change, we need to work out how much we rise up and how much we run across. We know it's exactly halfway between 80 to 100, so it's 90. We're rising up 90 and we're running across 4. So 90 over 4. So grab my calculator, 90 divided by 4 gives me 22.5. And because we're talking about income, money versus time, we're going to say $22.50 per hour. So this person earns $22.50 each hour. If you'd chosen another point, by the way, I just want to make it clear, somebody else might have chosen this point up here and worked it out as rising up 180 over 8 hours. They would have grabbed their calculator and gone 180 divided by 8, and they would have still got the same gradient. So you could have picked another point and have to pick the point I picked. So long as it's on the grid, work out how much it rises and how much it runs, you'd get the same gradient or the same rate of change. Right, here's our third example. We have the charge, maybe it's a taxi service charging us money in New Zealand dollars, and we have a distance in kilometers. So we're going to work out the gradient or the rate of change. Now notice it doesn't start at the origin this time. So here are the 2 points we're going to use to work out the rise and the run. But be careful, when we count up here, we're counting up 1, 2, 3, 4, 5 squares to get to 10. So each square represents 2. So we're going to go 2, 4, 6. So we're starting at 6. And then if we work out where we've risen to, notice we've got up to 30, but each square is worth 2. So 32, 34. We're ending at 34. So to work out the rise, we actually have to work out the difference between 34 and 6, which is 28. So we're rising up 28 squares and we're running across 8 squares. So 28 divided by 8 gives us 3.5. So we have a charge of $3.50 per kilometre. Right, well that's us. So thanks very much for tuning in and watching this video.